All right. Pressure treated lumber, often shortened to PT, is a special treatment that's applied to any kind of wood, really, when we want to give it some additional protection. Maybe it's going to be outside. Maybe it's going to be touching the concrete. Maybe it's going to be getting wet. Maybe it's going to be in ground contact. Okay. So what they do, they get a piece of wood, they put it in a pressurized chamber, and they punch all these little divots in it, and they pump it full of poison, essentially. Okay. That poison makes it so that insects, termites, powder post beetles don't want to eat it. That poison makes it so that mushrooms don't want to grow on it. Okay, fungal attack. We've all heard of dry rot. Okay, dry rot is a term for a mushroom that grows on wood and eats the wood. Okay, there's nothing dry about it. It's when the wood gets wet and then fungus is able to grow on that wood and consume it. Okay. Pressure treated lumber was developed in response to the declining availability of naturally decay resistant woods like redwood, cypress, and cedar. We can still buy those woods, they're still commercially available, but they're not as good as they used to be. Okay, we already cut down all the good trees. Okay, we weren't very responsible with the resource that we had. Okay, and so when I talk about old growth lumber versus the way we're producing lumber now, old growth lumber grew in a very competitive environment. It grew in a dense forest. It grew very slowly, and it grew straight, and it didn't have the luxury to make a bunch of branches. Okay, it had to get up to the sunlight before the other trees did, so that it could thrive, so that it would be the dominant tree in the forest. Okay, what happens when a tree grows slowly and it's kind of starved of sunlight and it's competing with other trees? You get really straight trees without a bunch of knots and really tight grain, and they have a long time to develop tannins, which are naturally resistant to pests, okay, fungus, insects. Okay, the way we're growing trees now, which is a great use of the resource, but unfortunately means we get a very inferior product. We're planting them like rows of corn, okay, big rows of Christmas trees, and they get all the water they could ever want, all the sunlight they could ever want. The problem is they just kind of grow however they want. Okay, they're going to do whatever they want. Maybe they want to grow crooked or whatever. They're going to sprout a bunch of branches out so they're all full of knots. They've got huge growth rings. Okay, they tend to want to split really easily. The lumber is very much of inferior quality. Okay, so in response to that, in response to the fact that we cut all the old growth trees down, we had to develop this pressure treated lumber. Okay, it is good for what we need it to do, but there are certain steps that we can take to significantly prolong the life of the pressure treated lumber and make it much more effective. Okay, one of those steps is sealing the end grain somehow. Okay, when you cut a piece of pressure treated lumber and look at the end grain of that lumber, you're going to see that the pressure treating, okay, sometimes it's brown, sometimes it's green, it depends on what the chemical is. It just goes around like a 1/4 inch perimeter around that board. Okay, that's as far as it was able to penetrate. As soon as you cut that board, that end grain is exposed. It's just a normal piece of wood. Okay, there's nothing magic about it anymore. And if it's getting wet, if it's touching the concrete, if it's exposed to the outside, bugs are going to get in it, mushrooms are going to grow on it, and it's going to get consumed from the inside out. Okay, I've pulled fence posts out of the ground, and there's like a 1/4 inch shell all the way around that's perfectly intact because that's where the pressure treatment was, but the entire core has been eaten by termites. Okay, so you can buy the material they use, the wood preservative that they use, and apply that to the end grain, okay? I don't know how effective that is, and all of these little puncture marks are kind of a testament to that. The reason there's all these little puncture marks all over it is because they have to puncture the wood all over the place just to get that poison to penetrate the wood. And this is peculiar to the Douglas fir that we have available on the West Coast. If you see pressure treated lumber on the East Coast, it looks just like a normal piece of wood, but with a slight kind of greenish, yellowish tint to it, okay? The reason is southern yellow pine is much more accepting of the pressure treatment process than Douglas fir, okay? We have to puncture the living heck out of that Douglas fir lumber to get that pressure treatment to take, okay? So I don't really know how great it is to just kind of brush some of that wood preservative on the end grain, okay? What I started doing, and I used to do that, the biggest reason I got away from applying the wood preservative to the end grain is that stuff is really nasty. It is so stinky, it's so gross, and it gets everywhere. It doesn't matter how careful you are. Once you're using that stuff, it's like you're covered in it. You turn around and you're covered in that stuff. So I'm not using it anymore. I started using paint. I would just get a can of white spray paint, and every time I cut a pressure treated board, I would just spray that end grain. I started doing that in class. The only problem was I had a hard time keeping some people from getting paint everywhere, okay? Everything was covered in white paint. Sometimes they got the end grain of the pressure treated board, okay? What I'm moving towards now is clear spray paint. You can get it all over the place, and you won't leave white paint all over the place. What we're trying to do is we're trying to seal up that end grain, okay? The end grain of the tree, think about it like a bundle of straws, okay? The end grain of the tree is where sap was transmitted through the tree, okay? It's open. It wants to absorb water, whatever it can. We're going to try and fill that end grain with paint so that it doesn't take on water, okay? All right, let's move on. Hopefully that all makes sense. Lumber defects are partly attributed to like the drying process. Okay, we're gonna buy wet lumber for the most part and use wet lumber. Okay, some people are shocked by that, but it's so much easier to cut wet lumber. It's so much easier to nail wet lumber. If we try and nail dry lumber, it wants to split apart. It's not very effective. Okay, wet lumber loses water over time, and as it loses water, if it loses water unequally, then the board twists and cups and crowns, okay? So I want to talk about some common lumber defects that we're going to encounter, okay? And a lot of times, like if we're framing walls, if we come across some like really nasty board, we're going to probably set that one aside. We kind of want to sort through our lumber a little bit, okay? If we like rated them, A's, A lumber is nice straight boards. We want to set those aside for like the kitchen or the bathroom, someplace where we're going to put cabinets on the wall, and we want nice flat walls to put cabinets against, okay? Maybe the B studs are going to be the ones that we use for general purpose framing. If we get some C's, maybe we're setting those aside and we're building like corners, and we'll talk more about this, but doing something where we'll be able to straighten that board out as we nail it, okay? If we get like a D board, maybe we're cutting that up for blocks or just burning it, I don't know, throwing it off a cliff, something like that, okay? But let's talk about some of these defects that we're going to encounter. This one is called bow, okay? From end to end, it's not straight, okay? Across the face of the board, it's not flat, okay? It's usually high on the ends, low in the middle. We're going to have like a little rocking horse kind of situation here. And if we flip it over, we're going to have a hump, okay? This defect is called crown. So if we sight down the edge of this board, okay, it's gonna be similar to bow. And let's say we sight down a board and it's high at the ends and low in the middle, okay? And then if we flipped it around, it would be high in the middle and low at the ends, okay? Across the edge of the board, it's not flat, okay? This bow we can deal with. It doesn't really matter. Bow, we can straighten out the studs as we're nailing sheet goods on and straighten that board out. That's not that big of a deal. Crown, we can deal with this also, but we have to keep in mind which way these boards are crowned. And for the most part, they're going to have some kind of crown to them. The critical thing is that we crown all the boards the same way. Okay? If they're all crowned up, that's fine. If they're all crowned down, that's fine. Your eye won't notice kind of a gentle radius on the wall, okay? And keep in mind, we are using an imperfect material, and we're trying to put flat sheets onto that material, but those sheets are just going to follow whatever the boards are doing, okay? But like I said, if everything's going in the same direction, you won't really notice it, okay? If you frame a wall and some of the studs are crowned up and some of the studs are crowned down, you're going to see the wall looking like a snake, okay? It's going to look very wavy. People are going to notice that, okay? We make a habit of always crowning lumber up, okay? So when I say crown up, that means we're going to set, when we build the wall, we'll set all the studs on the floor, we'll nail everything together on the floor, and then we'll stand the walls up. So when we set the stud down on the floor, we want the crown up. We want it to be high in the middle, facing up. So this board would be flipped around, okay? The reason is it's easier to nail the wall together. It doesn't really matter other than it's easier to nail the wall together. If the crown is up, it will be touching, it will be sitting on the floor at 2 points, okay? If we crowned it down, if we had it in this direction, the stud would want to be rocking as we're nailing that wall together, okay? All right, this defect is called cup. And most of the time cup presents itself is in 1x material or really wide lumber, okay? 2x12s are generally going to get cupped if we don't let them dry out. And a lot of times you can correct cup. Let's say you get a bunch of wood and it's got a big cup in it, okay? It means it's drying one side of the board, one face of the board is drying faster than the other side of the board, okay? And it's curling up, okay? Flip the board over, okay? And then the sun will have a chance to dry out that other face of the board. It doesn't always work, but I've been able to salvage some boards using that method, okay? Twist, this one's kind of a big pain sometimes, depending on what you're trying to do. Again, when we're dealing with like framing lumber, this isn't that big of a deal. We can kind of twist the board around as we're nailing it together and kind of straighten it out a little bit, but it's when the corners of the board are not flat, okay? If we sight down a board and it's twisted, it means like, for example, this corner's higher than this corner. They're not flat. And then this corner is higher than that corner. They're not flat. The board's been like, each end has been twisted in opposite directions, okay? That one's not as much fun. This defect is called wane. And what that is essentially, this is the end of the tree, okay? We took a log and we started cutting rectangles out of it. And then this is where it started turning back into bark, okay? So this is the radius of the outside of the tree. It's not that big a deal, but we want to try and conceal the wane if we can. Okay, so if we're building like a corner or a channel, or we'll talk about what those things mean later on, but we want to try and avoid having the wane where we're trying to nail a sheet good onto it. Okay, because as you can see here, this is supposed to be 1.5 inches thick, but we've only got 1/2 inch of flat material. So it's going to be really difficult to nail into that.